Okay, this is the continuation of the logarithmic derivatives. And I just noticed that I was reviewing the former video and I noticed that the arrows were missing in the formulas I wrote earlier. So if y is equal to log of u base e, this implies that y prime is u prime over u ln of a. So apparently I forgot to put the arrows and I just put equals, or I don't even remember. I didn't put anything. So this is the function itself and this is its derivative. Again, y equals ln of u implies that y prime, its derivative, is equal to u prime over u. So just a quick little correction about the arrows that were missing. And here I just intend to give you some examples of different derivatives of different functions involving logarithmic functions. The first one says ln of x. So we want to take the derivative of ln of x. So this is actually ln of u. So I can use actually this last formula at the bottom. We know that derivative of ln of u is u prime over u. So it's going to be derivative of the sine function over sine function itself. So here I'm going to go y prime is equal to derivative of sine is cosine. So it's going to be cos x divided by sine x, which you can say it is actually cotangent of x. So very simple, very quick. I'm just applying the four logarithmic formulas we learned. Log of 5x minus 3. So the base here, it's not like it's forgotten. The base is 10 actually, because whenever you don't put the base of the logarithm is understood to be 10, it's called common logarithm. So we want to find the derivative of the common logarithm of 5x minus 3. And 5x minus 3 plays the role of u for us. So this is, again, e. I just noticed. I want to make sure that it's correct. Log base a, not b. So the derivative of log of u base 10 would be u prime, which is 5 in the numerator, divided by u, which is 5x minus 3, and then times ln of a, which is ln of the base of the logarithm. In this case, base of the logarithm is 10. So it's going to be ln of 10 in the denominator. We cannot simplify any further, of course. So direct application of the formula. Next one, it's log of a cubic function base 2. So which one should I use? Definitely not the first two, because those are just log of x and ln of x. This one is log of u, some function of x, and the base is 2. So I'm going to be using this third formula here. What plays the role of u is the cubic function. So u prime in the numerator would be 3x squared minus 2x all over u, which is the cubic function itself. I repeated it. And ln of a in the denominator, and that is ln of 2 in the denominator. We can't simplify. You could factor x out in the top, but it doesn't matter. So that's the final answer. This one is a quotient involving logarithm. So 1 plus ln x over 1 minus ln x. So we know that we have to apply the quotient rule. So the derivative would be derivative of top, which is 1 over x, according to this formula, because you know that log x base e is actually ln of x. It's the same thing. So derivative of top is 1 over x times bottom, 1 minus ln of x, and then minus derivative of the bottom, which is negative 1 over x, times the numerator, which is 1 plus ln of x. There you go. Nice trick. So u prime v minus v prime, which was negative 1 over x, times u, all over the denominator squared. Okay. So now y prime would be 1 over x, and 1 over x would be 2 over x if you collect like terms. This is negative ln x over x, and that would be positive ln x over x, which cancel out each other. So why should I bother? You know, let me write it. It's okay. Negative ln of x over x plus ln of x over x. They cancel out each other. They add up to 0. So you don't need to even write it. So final answer will be 2 over x, 1 minus ln of x all squared. That's the final answer for this derivative. Okay, we go over there, top, y equals x squared times ln of x. That's a product, so I have to apply the product rule. So the derivative would be 2x, that's u prime, times v, which is times ln x, and then plus v prime times u, derivative of ln of x times x squared. So that would be 1 over x, according to this formula, times x squared. And this was actually ln of x. Okay, so x squared over x is going to be just simply x. We can simplify, and then we get 2x ln x plus x. And you can always, of course, factor out x. So we end up with x times 2 ln of x plus 1 if you factor x out. Simplified answer for y prime. Again, I forget this prime here. All right, last question here. It's a logarithmic function which is raised to the exponent of 11. So it's ln of 10x raised to the exponent of 11. It reminds me of u to the power of n formula. So the derivative would be n times, in this case n is 11, u prime, which is the derivative of inside, and then times u to the power of n minus 1, which is ln of 10x raised to the exponent of 11 minus 1, which is 10. There you go. So here I just have to write the derivative of inside. The derivative of inside is ln of 10x. What's the derivative of ln of 10x? So I have to apply this formula, ln of u. Ln of 10x will be derivative of 10x over 10x. The derivative of 10x is just 10. So 10 divided by 10x, basically that's what we should write here for the derivative of inside. Derivative of ln of 10x, in other words. So simplifying, 10 over 10 just cancels, so we have 11 over x times ln of 10x, all raised to the exponent of 10, and that is the final simplified answer for this function. So I try to give you a variety of examples here, a quotient rule combined with logarithmic differentiations, and a product question, a power question, and some other type of questions involving chain rule. So these kind of examples, you should be able to do them. In the textbook, I doubted if there's any reference to these kind of questions, but we are preparing for university, so it doesn't matter if the textbook mentions some formulas or they don't mention. You just have to know these 4 formulas for derivatives of logarithmic functions. Okay, thank you for your attention. Then we're going to continue with exponential derivatives of exponential functions. Okay, keep practicing and keep well.